From the previous section, we know that the function 1 over 1 minus x coincides with the power series, the sum from 0 to infinity of x to the n for the absolute value of x less than 1. And of course, this comes from our formula for a geometric series. The sum of a times r to the n minus 1 is a over 1 minus r if the absolute value of r is less than 1, and the series diverges if the absolute value of r is greater than or equal to 1. So for the series, the sum from 0 to infinity of x to the n, we have a is 1 and x is r, and we know that the domain for this power series function is all x with the absolute value of x less than 1. And we also know from this formula for geometric series that the sum is 1 over 1 minus x when the absolute value of x is less than 1. So this gives us what we call a power series representation for the function g of x equals 1 over 1 minus x on the interval from minus 1 to 1. Now note that this function g of x has a larger natural domain than this interval from minus 1 to 1. So this power series expression is only valid for x values between minus 1 and 1. Notice also the nth partial sum of the above power series is a polynomial in x. It's 1 plus x squared, etc., plus x to the n. And as n goes to infinity, the graphs of these polynomials get closer and closer to the graph of f of x on the interval from minus 1 to 1. So these polynomials for large n are very good approximations to the function g of x equals 1 over 1 minus x on the interval from minus 1 to 1. Now, of course, the polynomials have a life outside that interval, as does the function g of x, but on the interval from minus 1 to 1, the graphs of the polynomials get closer and closer to the graph of g of x. Well, these are the questions we want to answer. Given any function, can I find a power series representation of that function? So for example, if I take the function f of x equals 1 over 1 plus x to the 7, or h of x equals the natural log of 1 plus x, could I find some power series that coincides with this function on some interval? And of course, part of the same question is, if I have a power series expression for the function, for which values of x is that power series representation valid? So suppose I know that 1 over 1 plus x to the 7 is 1 minus x to the 7 plus x to the 14 minus x to the 21. In other words, the sum from 0 to infinity of minus 1 to the n x to the 7n for some values of x. How can I figure out for which values this power series coincides with the function? And the second question is, what's the point of writing a function as a power series? And in fact, there are a lot of uses for being able to do this, and writing a function as a power series is going to be a very useful tool in your engineering courses and your physics courses, and it's definitely something that's going to be used a lot in later courses. For starters, suppose I know that this formula holds 1 over 1 plus x to the 7 equals the sum from 0 to infinity of minus 1 to the n x to the 7n for, say, values of x less than 1, then that allows me to calculate the sum of a whole new set of series. For example, if I take x equals 1/2, then the sum from 0 to infinity of minus 1 to the n times 1 over 2 to the 7n is 1 over 1 plus 1 over 2 to the 7. So as with geometric series, if I actually have a nice closed formula for the sum of the power series as a function of x, then I can actually sum the series for the values of x where the representation holds. Also, I can use the polynomials to approximate the function 1 over 1 plus x to the 7 when the absolute value of x is less than 1. So for example, I might just take the first 3 terms, and that gives me the polynomial 1 minus x to the 7 plus x to the 14, and that's a good approximation to 1 over 1 plus x to the 7 for x between -1 and 1. And probably the most important use of power series is in differentiation and integration. I can either use a polynomial approximation to a function to approximate an integral, or I can integrate a power series expansion for it term by term. So for example, if I want to integrate 1 over 1 plus x to the 7, I could say, okay, well, 1 over 1 plus x to the 7 is approximately 1 minus x to the 7 plus x to the 14, so its integral is approximately equal to the integral of that polynomial, which is x minus x to the 8 over 8 plus x to the 15 over 15 plus some constant.